Okay, friends, welcome to part 4 of our video presentation on chapter 8. In this part of our video presentation, we'll talk about object-oriented techniques or methods of system analysis and design. So what is the essence of object-oriented methods that have been developed relatively recently in comparison to the procedural methods and the ones and they are gaining increasing popularity and use? Now, the essence of object-oriented techniques or methods is that they facilitate object reuse and quick, rapid prototyping of information system solutions. So this is the essence. I mean, this is the main difference between procedural approach and the object-oriented approach. Under procedural approach, once an organizational problem is discovered, a team of business managers and system analysts or business users and system analysts, they prepare detailed design documents specifying as precisely as possible what kind of information system solution needs to be developed. And then programmers divide this description of the solution, and they write thousands of lines of code from scratch to develop the solution. And typically it takes months, if not years, to develop a solution, a software-based or information system-based solution to an organizational problem. Now, object-oriented approach is much more rapid. Once the problem is defined, an organizational problem is defined, the object-oriented programmers, they search a library of objects, let's say, in a particular programming language development environment. So objects are basically pre-written chunks of code, and they try to find the objects that will be relevant for the problem that was identified previously. And within days sometimes, a few objects are used or reused to put together a prototype of an information system solution. And then once this prototype is created, it's presented to business users to get their feedback, and then based on that feedback, other objects are added or existing objects are customized. Now, object-oriented approach is designed to speed up the system analysis and design process, and sometimes, designing an information system solution under the object-oriented approach is a matter of weeks, not months or years. Now, what is the essence of object-oriented approach? I'm not sure who exactly can be credited with the creation of the object-oriented paradigm in programming or information systems. I think it's life itself. It's Mother Nature who gave people this kind of way of thinking about developing code, developing information system solution. Some of the fundamental principles of object-oriented object-oriented paradigm as used in programming and system analysis and design are as follows. First of all, you have encapsulation, meaning an object contains data and related operations or methods, as they say in object-oriented programming. So basically, under this paradigm, developers, they view world as a collection of objects. A student is an object, a car is an object, a class, meaning course, like this course, is an object, an instructor is an object, and so forth. And each object is characterized by certain properties or attributes, certain data points, and also each object can do something. For example, an object or a class called student can register for courses, can add courses, can drop courses, can retrieve grades, can calculate GPA, and so forth. So that's an encapsulation. So an object is some kind of unit of reality with methods and data being encapsulated. Inheritance, I would say, it's the most powerful concept under the object-oriented paradigm. Inheritance means one class of objects can inherit characteristics from others. So, for example, you can create an object called Murray State University student, and this object will inherit all the data points, all the attributes and methods from a more generic object called student. Right? Now, if you think about it, it's a very profound idea, the idea that one object can inherit things from the other object, because if one object can inherit things from another object, can inherit methods and properties from another object, then you don't need to redefine all those objects. Again, Mother Nature is the ultimate tutor and example here. Now, think about the reproduction process. Horses create horses in a way, they produce horses without designing them, right? They just produce baby horses, and those baby horses, they inherit, characteristics from their father and mother. Now, you understand that a horse or any kind of biological organism, especially human, because of the brain that is way more developed than that of some other biological forms. Any kind of biological organism is an infinitely complex system, right? And think about it, you don't need to have a degree in biology to reproduce, right? It's just all based on this inheritance. Now the same thing applies to coding. You don't reproduce things, you don't write code for your own objects, you just create objects that inherit things from other objects. So this allows for reuse and replication of existing designs, and all this saves money. Polymorphism, it basically means you can treat child objects the same as parent objects. In other words, if one object is a child object is derived from another object, then you can assume that the methods will be the same. You can call them. And one thing that I mentioned that I forgot to mention as a part of the encapsulation is that it allows for loosely coupled modules and reuse. It means that sometimes to use a particular object you don't need to have a full understanding of what's happening in that object. Something that will save time and also intellectual capacity on your side. And then those things can be like if you have dependencies between objects where one object is a child, then you can use the same methods, you can try to access the same properties. So again, all this saves time in terms of not writing code, reusing code, and in terms of not trying to understand the entire thing. You just understand a portion of the object that you need for your own work. So this is the essence of object-oriented paradigm in programming and system analysis and design. Now there's something called the Unified Modeling Language, which is a collection of different standards or modeling techniques. And a number of object-oriented analysis and design methods are included under this UML family of standards. For example, use case diagrams, sequence diagrams, and class diagrams, and we'll look at some of them. Now, use case diagram, again, it's a part of UML modeling techniques, or system analysis and design methods specified by UML. So here we have a use case model. A use case model is a logical model that gives somebody the essence of an information system, what the system is all about. And this logical model is defined in terms of actors, depicted right here, and also processes that those actors can invoke. Now, those processes are basically functionalities or functional points, and later on, developers may divide those functional points among their teams to develop them. But this is like a simple way to describe what the system will be all about. You're saying, well, an existing member will be able to log in, check account, browse catalog, submit rental orders, and then shipping clerk is responsible for accepting orders. And then once the order is accepted, a message is being sent to the inventory system. So it's a quick way to rapidly create a logical model of an information system. Here you have a more technical approach. It's called sequence diagram. So basically, there's a sequence of interactions, let's say, between a user and certain classes, and those classes are sending messages back and forth between one class. Once it's executed, sends a message to another class. So here you see a procedure that looks like a procedure that describes the way a student registers for courses. And in order for a student to register for courses, this particular student needs to evoke or launch a number of classes like registration window class, registration entry class, course offering class, course class, a new registration class, and all those things, they exchange messages. In other words, messages are being sent from one class to another using this particular sequence. A class diagram, it's a way to describe classes and their relationships. Another object-oriented modeling approach under the family of UML standards. Okay, friends, so this concludes part 4 of our video presentation, Chapter 8, the part devoted to object-oriented system analysis and design methods. Thank you for listening.